Okay, so we have reached the final method of solving systems of equations, and this is called the elimination method. So, the goal of the elimination method is when we add the two equations together, we eliminate a variable. So, what we need to happen is we need to have one variable in both equations to have opposite coefficients. When I say opposite, what I mean is that if your coefficient of y in your top equation is -2, then your coefficient of y in your bottom equation would need to be +2. This would help us get to our goal of eliminating a variable. Well, in number 1, my x's do not have opposite coefficients, but my y's do. My top equation, my y value has a +1 coefficient. In my bottom equation, my y value has a -1 coefficient. Those are opposite coefficients. So that's good. That's a good thing. Because when I add these two equations together, what's going to happen are my y variables are going to go away. So adding these two equations together, a 3x plus a 2x comes out to be a 5x. A plus 1y plus a -1y eliminates. Those variables disappear, which is good. That's what we need to happen. And this will equal a 10 plus a 5, which is a 15. So now this pink equation is an equation with just the variable x in it. I'm going to find x by dividing by 5, and I wind up with x is equal to 3. Now remember, we need to find the corresponding y value. We need to find an ordered pair. So what I'm going to do is I'm going to take that x value of 3, and I have a choice. I can either substitute that x value of 3 into my top equation that I just boxed in green, or I can substitute that x value of 3 into my bottom equation that I just boxed in yellow. It does not matter which equation you choose. It is your choice. It does not matter. I'm going to do the bottom equation. So I'm going to put 3 in for x in my bottom equation. And now I'm going to solve for y. And I get a y value of 1. So now I write my answer as an ordered pair. I had an x value of 3, a y value of 1. This is my solution. A reminder, you can substitute both of those x and y values into both equations to see if it works out to check your answer. All right, moving on to number 2. Well, if I look at my x's do not have opposite coefficients, and my y's also don't have opposite coefficients. So I'm going to need to do something to either one or both of these equations to help me obtain opposite coefficients. Now, my y values have opposite signs for their coefficients, so that's actually good. So let's, it's your choice of whether you want to eliminate x or y. For me, I'm going to eliminate my y's because I have opposite signs already. But if you wanted to eliminate x's, you can completely do that. To be able to eliminate the y variables, I would need to multiply my top equation by my coefficient of y in my bottom equation, and I would need to multiply my bottom equation by just the number coefficient of y in my top equation. I don't want to multiply by -2 because then we're not going to have opposite sign coefficients. We're just going to have opposite coefficients with the same sign, and that's not what we want. We want the coefficients to have two different signs, one to be negative, one to be positive. All right. I do need to multiply the whole equations by these numbers because when you multiply an entire equation by a number, you do not change the value of your equation, you just change how it looks. If you don't multiply the entire equation by the same number, then you actually are changing the value of your equation, which would yield to the incorrect result. So let's go ahead and multiply the top equation by 3. I wind up with a 9x minus a 6y is equal to a 3. My bottom equation, multiplying everything by 2, I wind up with a 16x plus a 6y is equal to a 4. And now if we look at my y variables, both of them have opposite coefficients. One's a -6, one's a +6. That's what we want. So now a 9 plus a 16x is a 25x. A -6y plus a 6y cancels out. So I eliminated a variable, which is exactly what my goal was. And a 3 plus a 4 is a 7. So now I'm going to divide both sides by 25 to get x is a value of 7/25, which isn't very nice, but we will have to work with it. Now to find my y value, I'm going to take that 7/25 and I'm going to put it in for x in one of my original equations. It does not matter which one. I'm going to do the top one this time. So I have a 3 times my x value of 7/25 minus 2y is equal to 1. So a 3 times the 7/25, I do the 3 times the 7, which is a 21. So I have a 21/25 minus a 2y is equal to a 1. I'm going to subtract 21/25 from both sides. And I wind up with a -2y is equal to, and a 1 minus a 21/25 is the same thing as a 25/25 minus a 21/25. So I wind up with a 4/25. And then I'm not going to be dividing by -2 because dividing by -2, I should never divide a fraction by something. So instead I'm going to multiply that by the reciprocal of -2, which is a -1/2. So I wind up with y being equal to a -4/50, which can be reduced because 4 and 50 are both divisible by 2. I get a -2/25. So my x value was 7/25. My y value was -2/25. This is my answer. All right, number 3. My x's do not have opposite coefficients, but my y values do. So we can jump straight into adding our two equations together. A 5x plus a 1x is a 6x. A -2y plus a 2y cancels, which is exactly what we wanted to happen. And a 30 plus a 6 is a 36. Now I'm going to divide both sides by 6, and I wind up with x being a value of 6. Now I'm going to take that value of 6, I'm going to put it into one of my original equations. It does not matter which one. I'm going to do the bottom equation. So I have a 6 plus a 2y is equal to a 6. Subtracting 6 from both sides, I wind up with a 2y is equal to a 0. And dividing by 2 on both sides, I wind up with y is 0. So my x value is 6, my y value is 0, my answer is the ordered pair 6, 0. All right, moving on to number 4. Now in number 4, my y values have the same coefficients, and my x values do too. Now I need a pair of opposite coefficients, meaning one of them needs to be negative. So you get to decide whether you want to get rid of x's or y's. It does not matter. I'm going to get rid of the x's. In order to get rid of the x's, they already have the same coefficient of 9. I need one of them to be negative. So I'm going to choose one of my equations. It does not matter which one. I'm going to choose the top equation, and I'm going to multiply that whole top equation by -1. So I wind up with a negative 9x minus an 8y is equal to a negative 15. Now I'm going to add my two equations together. A 9x minus a 9x is a 0, it wipes out. An 8y minus an 8y is also a 0, it wipes out. So I actually eliminated both of my variables. And a 30 plus a negative 15 is a 15. Well, this should kind of ring a bell for you because we've dealt with these types of equations before when we were just solving single equations. When we were solving single equations, if your variable is eliminated and you wound up with a false statement like we have here, because 0 does not equal 15, then your answer was no solution. Meaning, on the graph, these two lines would be parallel. They would not intersect. Another thing is, if we think back to when we were doing graphing, these two lines would have the same slope, but different y-intercepts. Now, if you wound up with a true statement, if you wound up with 15 equals 15, or if you wound up with 0 equals 0, and those are true statements, then you would have an infinite amount of solutions. So keep that in mind as you're practicing. All right, so that is how we solve systems using the elimination method.